Good morning to all. I am Dr. P. Manoj Kumar, Assistant Professor, Department of Electrical and Electronics Engineering, Banariyamma Institute of Technology, Tamil Nadu. So I am going to present my paper Design of Electronic Control Unit with Black Box for Grounded Vehicles. My paper ID is T9S34 P585. Okay. Next one, outline of my presentation. First one, introduction. Second one, literature survey. After that, objective of my work. Then design of electronic control unit with black box. Then hardware implementation. After that, results and discussion. Then conclusion and future scope. Last one, reference. First one, introduction. In the beginning of 1990s, mechanical and hydraulic systems were replaced by electrical systems in designing of electronic control unit. Electronic control unit with the support of black system is employed for the avoidance of vehicle accident. Here I am used here microcontroller for obtaining the vehicle information. Next one, extra objective is electronic control unit with the support of black system to improve the reliability and readability of the vehicle accident. So these are the introduction. So these are the some literature survey I took. These are the summaries of finding the literature survey. Next one, objective. So already black box is available in a flight, but in a ground vehicle it is not available. So I am going to, my plan is going to implement that black box with the help of ECU. So ECU is a heart of all the car. So all the informations are controlled by using only the electronic control unit in the vehicle. Okay. So this is my objective. So first objective, to develop a universal control unit that can be used to analyze the performance of fuel consumption in the vehicle. So second one, to design the control area network to examine the performance among the sensors and the actuators. Last objective, to develop a electronic control unit with the support of black box system to obtain performance of the vehicle during abnormal condition. So these three are the objective of my work. This is the block diagram of ECU. Here I used microcontroller. So in the left side, so these are the sensors I used in my work. So these are the display unit. So here I used dose sensor, IR sensor, then alcohol sensor, ultrasonic sensor. Here alcohol sensor is used to whether the driver is consumed alcohol or not. If driver is consumes alcohol, it will detect that level and send it to a controlling unit. Okay. So next one, ultrasonic sensor. So it is used to detect the obstacle present in the in front of the car. If there is any obstacle present, means it will data will be sent to the receiving side. So here I used door sensor. If door is unlocked, it will automatically send the signal to the control unit. Okay. If driver is not wear the seat belt and nearby passenger also not wear the seat belt, that also indicated by using seat belt sensor. So these are the sensors I used in my work. So here I used some transferring section. First one is a Bluetooth. It transfers the data from the controller to the controlling station. So here I used the communication protocol. Here I am used to Bluetooth. Next one, SD card. So this is the memory device. SD card. Here I used SD card as a memory device. So it stores all the information of the vehicle. So whether the driver will consume alcohol or not. So whether the obstacles present in front of the vehicle or side of the vehicle, all the, whether the door is closed or not, all the informations are stored in the memory card. So this is the outline of my ECU. Next one, electronic control unit with the black box for communication with the use of two controllers such as master and slave. So here I used master as a microcontroller. Slave I used slave for monitoring purpose. So here I used LabVIEW for the slave data acquisition. Okay. So signals from seat belt sensor, door sensor, alcohol sensor, ultrasonic sensor, and signals from IR remote is considered as an input to the master controller. Okay. Next one, embedded microcontroller is used to interface the electronic control unit and the black box system. So this is the simulator. This is the front panel of the black box. So if there is any abnormal condition, otherwise if any accidents occur means, so we take that black box and connect it into your system. So in that system it will appear this simulation. So here whether the seat belt is weird or not, so where the accident occurs, and whether the driver consumes alcohol or not, so whether the door is locked or not, then also what's the temperature of that vehicle, what's the speed of that vehicle, all the informations are stored, are seen in the screen. So this is the front panel of the, here I used LabVIEW. So this is the simulation of alcohol sensor. So here the alcohol sensor I used. So simulation is executed by the comparison of amplitude and time in the range up to 100 milliseconds if considered for the experimental work. When the alcohol sensor resulted with higher amplitude, vehicle is locked. Okay. So next one, this is the sensor value. So what's the speed sensor value, alcohol sensor value, distance value, temperature value. So based on this all the informations are stored in the memory. So next one, this is the sensor result analysis of the sensor value. So whether the seat belt is, here I used true or false. True denotes whether seat belt is weared. False denotes the driver or passenger will not wear the seat belt. Okay, and also door lock, whether the door is locked, whether the accident is occurred in the front, side or rear. So based on all the information, what type of vibration occurs if the vehicle hit to the nearby vehicle or something happening means, so how much vibration it occurs. The data, all these data are stored in the memory. So based on that information only we can analyze what type of accidents, so which is the under which condition the vehicle is accident or abnormal condition. All the data can be analyzed with the help of this value only. So this is the part of hardware implementation of the electronic unit. So here I used a controller, sensor, and also here I used data acquisition with the help of National Instrument, and also I used NSCDO. So this is the hardware implementation. It's a part of hardware implementation of the electronic control unit. Conclusion. Real-time controller area network and UCs with black box system were designed for achieving effective vehicle data communication for preventing the vehicle accident. Information transmissions between different vehicles are improved by presenting a CAN in automobiles. Bit rate deviations is reduced for 48 MHz. So this is the scope of future work. Here I am going to develop a high-tech or hybrid ECU which is operated in various ranges of vehicle to provide more security framework which consists of secured vehicle data communication mechanism for minimizing the accident. Here next I am planning to build an anti-brake control system introduced in future hardware implementation for controlling the vehicle future. So these are my reference. Thank you. If you have any queries, you can ask.